testing. You're gonna need note paper. There's lots of notes to take. There's a lot of like, if this, then you do this, if that, you do this. So kind of pay attention to all those. Great, already, huh? Yeah. Give a synopsis of it. All right, so hypothesis testing is you're going to be given a scenario with like, they're going to tell you this is how many people do whatever. And then they come up with an alternative like, oh, I don't think that many people do it. I think more people do it. Or I think less people do it. You know what I'm saying? So they'll give you a scenario and then you are going to have what we call an alternative hypothesis. And then through mathematics, you're going to prove, was the original good or was what we thought was good going to work? Does that make sense? So in a nutshell, that's what we're going to be doing. So the steps that kind of go with it, the first thing I want to kind of give you, the first things I want to give you are, so the first guy we're going to look at is what we refer to as the null hypothesis. Null being the little zero. Okay. So the null hypothesis is what's given to you originally. This is what's true from what the scientists say. On the blue shirts, you want to change the blue ink. So the null hypothesis is like what's given to you in the question itself. Then you have what we call H1, and I've also seen it in some books as HA. Our books no, but for future reference, okay? And this is what we call the alternative. Okay, so the alternative hypothesis. And so when we're discussing the null hypothesis is such that the mean is going to be equal to the mean of the null. We'll talk about what all that means once we start building on it. Okay, and then you come out and say, no, I really think more people do this, or I think this happens more often, or I think there's an increase in that. Or you could say, no, I definitely think it's less than what they originally said. So there's options that it could be more than, or it could be less than, or it could be not equal to, not the same. So I'm not telling you whether it's more or less, it's just the fact that it's different, okay? So that brings us into how we test the alternative. So the first one is when your alternative is going to be less than the original null. And this is what we refer to as a one-tailed test, okay, for decrease, meaning less than. The next one, alternative hypothesis. There, I found one that's pretty. And it's going to be where your mean, we don't have, we can put one, whatever, is going to be greater than that. And this is also a one-tailed test for increase, bigger than. And then last but not least, where it is not the same as that, and it's a two-tailed test for difference. Okay. as a visual example, it's going to be a one-tailed test where it's less than. That's this shading. This guy is a one-tailed test where it's greater than. That's this shading. And then a one-tailed test where it's different. It could be here and or here. Are we cool so far? Yeah, as far as we're gonna be. Okay, so if we're talking about working and trying to figure out, let's say I have a sample that's normal, and we know, we talked about this the other day a little bit, okay? And so what we're going to talk about, and this is a little bit new, but I will get into greater detail. Oftentimes we take the variance and we divide it by the sample size, and we'll discuss that. And they'll be given to us during this particular type of problem. So let's say I have a normal curve, and we're going to go, just going to draw a picture. 1.08, my mean is 1.14, okay, and over here I've got 1.20. So oftentimes what's going to happen is when we start calculating our probability with, yes,
Will you read me the numbers underneath the curve?
1.08,
Okay,
1.14, and 1.20.
thank you.
Okay. So what we're going to do is we're going to calculate our probability, and then we're going to compare it to what we call a critical number. So sometimes we compare it to a 0.1 differential, like with if it's greater than 0.1 or if it's less than 0.1, where does it fall into our norm? And I'll show you all that. I just want to kind of give you the idea of what we're going to be doing. We could do so a 5%, which is 0.05 critical region. Okay, and that's typical, the 5%. With 5% validity, are we where we want to be? Is it bigger than? Is it smaller than? So sometimes what happens is when we're looking at the rejection, whether it's greater than or less than or not equal to, let's say that I want it to fall into with 5%, I want it to fall into that place over there. Okay, I'm going to show you how that looks, how it all comes into play. And so what happens is we end up having an acceptance region, and then we have a rejection region. So we're going to calculate numbers, and we're going to say, is it falling into our acceptance region or our rejection region? Okay. And if our picture was going the other way, where our little shading was on this side, this would be our rejection region, and this would be our acceptance region. Yes?
What's that?
What's what?
Like, it falls into the...
Oh, when we calculate them, we're going to look for our probability that this happens. We're going to, I'm going to do problems with you, so you'll see what the it is. But we're going to calculate a probability, and then we're going to say, does it fall to the right on that curve, or does it fall to the left? In which way did we want it to fall in the first place? So it's going to pull it all together when I do them. It's not the most, you'll be fine, we'll be fine. I promise I'll make it as painless as possible. Okay, so I promise, but for now I want you to know, like, if I'm talking about HO, what is it? If it's, you know, the null, what is that? Sort of thing, okay? And so to carry out a test, we're going to do steps. So step number 1, we're going to define the null and the alternative hypothesis. So how you earn your points literally are following these steps, and I'm going to show you how that looks. So number 2, we're going to decide a significance level. I'm going to explain that to you. Step 3, we're going to determine a critical value. We're going to calculate the test statistic, binomial, normal, eventually you're going to learn Poisson. Decide your outcome. Whether it's in the rejection region or acceptance region. And then state the conclusion in words. Then it gets even more exciting when you have to figure out if there's errors involved. Just saying. Okay, so we're gonna do a problem. I'm gonna do it slowly, and then we're gonna see how we feel about this. Okay, so does everybody have all this written down? All right, I'll read the problem to you, and then we're gonna do the, so experience has shown that drivers on a racetrack in a simulator, so they're doing it in a simulator, okay. So experience has shown drivers on a racetrack in a simulator crash 40% of the time. So drivers in a simulator crash 40% of the time, okay? Are we good so far? So, this group decides to run a simulator training program to reduce the number of crashes. So they're going to do training to reduce, bless you, the number of crashes. Are we cool so far? To evaluate the effectiveness, this group, this business allows 20 drivers okay, one by one, to use the simulator okay, and then they count how many drivers crash. then it says 4 drivers crash. No, that's a given. 4 people are gonna crash. Test the effectiveness. Okay, of the training program. At a 5% level of significance. All right. Okay, so write all that down and then I'll explain how this goes. So first of all, let's pick out what we think before we even know what we're doing. What do we think are important informations given in this particular problem?
40% crash rate.
We have a 40% crash rate. We have a 40% crash rate. That seems like a lot, right? What else do you think is important here?
4 drivers.
We got total of 20. And then you said 4. So then 4 drivers. Okay. 4, so 4 of them crash. Anything else?
5%.
We have a 5% significance level, so that's where our rejection region starts to come into play. So the it that we were looking for in this case is what's happening when we do our little math. Are we above or going to be below where that 5% significance level falls into play? And there's one more thing in here that's really, really important.
Is it 1 by 1?
1 by 1 is kind of important because they're individually doing it. It reduces the crashes. So what does reduce mean? Lower, smaller, okay? So we're looking for, so they're saying 40% of the people crash. However, they're gonna get this training so it should lower the number of crashes. Indeed, did that work or not? So that's kind of what our test is about. Lunch, done. Okay, are we cool so far? So that's all the stuff we're gonna pull together. Let's have fun. So how do we earn our stuff? First thing, we're going to define our null and our alternative. So the first thing you're gonna do is you're going to define what x is. Let x be the, and what are we measuring here? Number of crashes. Let x be the number of drivers that crash, you know, because it's drivers. Step 1, define your x here, okay? And then we're going to figure out what type of test are we looking at. So right now we have 2 things to think about. We have binomials, we know. We've embraced binomials, we did them last year. We have done normals. You are going to learn others, but I'm going to specifically keep with binomial and normals for this chapter. That way we're comfortable with the actual probability of it. It's just how do I set it up thing, okay? So is it a binomial or is it a normal, and why? What is it? Okay, I say yes, but why? What makes it a binomial? There's 4 criteria, right? So let's talk about what the criteria are. What's the first one? Finite number of trials. What's our finite number of trials here? 20. That's a decent number. If it told me 120, I might consider it being a normal, yes? Because that's a big number. 20, that's doable. Okay, so far so good. What else?
Independent trial.
Independent. What important information was in there that came up with independent?
1 by 1.
1 by 1. So every driver gets in there and 1 by 1 they're doing their thing. It's independent. And then like I crash, does it put bearing on the next person? They don't crash, they could crash, but it doesn't matter what I did, right? So independent. What's the next one? We have success or failure. What's the success? Well, it's I crash or I don't crash, right? What are we testing here? So we're trying to figure out whether they do or not, right? And then last but not least,
Consistent
constant probability, which is what? From the very beginning,
40%.
40%. I'm saying 40% of those people are gonna crash. These guys say, we're gonna do a training and we're gonna make it less. Okay, so are we cool? So it is indeed a binomial. So this is the next thing you do. Okay, what goes here, and then what's the next thing? 20. And then what's my next guy? 0.4. All right, are we cool so far or not? We're cool? We're okay? So step one, I'm not quite done with step one yet because we're defining the null and all that, but we're kind of like telling everybody, I know it's a binomial, this is what it's about, okay? Now is really the step one kind of thing. We have to figure out what our null is, and then we have to figure out what are we trying to test against. So what is the actual statement saying in the very beginning? So our null is what's given to us, and this is what we should expect to be true. So what is our null here? What is the probability going to be? 40. So the null is that the probability is indeed 40%. And then the next breath, what is the alternative? So what am I trying to prove? What is this company trying to prove? That no longer will the probability be equal to 40%, but it should be less than 40%. All right, that was step one. All right, how we feel? We can take it in a word problem and dissect it in that manner. Once again, the ones we're gonna do are binomial or one that we have to convert to normal, because that's all you know yet, okay? And then at the end of the year, we're gonna learn, Poisson as we go, and then we're gonna throw hypothesis testing back in, where it's gonna be, are you gonna do binomial, normal, or Poisson? That sort of thing. So, all right, but it's good to have like a feel for it now. All right, are we good so far? Yes, okay, so then we have to figure out the significance level, okay? So the first thing we're going to do is we're gonna figure out the test statistic of this. So, and we'll come back to the significance level because it kind of, it goes hand in hand. So the first thing I need to do is I need to figure out the probability of what's really happening here. So we are going to do the probability that x is less than or equal to, what are we looking at? What are my numbers over there? How many people did they say crashed after they got trained?
4.
Only 4, right? So potentially for it to be less, does it make sense that I could have 0, 1, 2, 3, or 4, right? Does that make sense? So we're looking for the probability that it's less than or equal to 4. Okay, now's the stuff you're really comfortable with, so I'm gonna have you do this particular one. So it's, are you guys good that it's 20? The first guy is 20, choose 0. And then what's the probability of success? 0.4, correct? Are we cool? And then to what power?
0.
To the 0 power, and then 0.6 to the what power?
20.
20th. And then what do we do with all of these guys?
Add them.
We add them all up. So I'll let you play with that for a minute, please. Okay, does everybody agree with that? Okay, so we're getting 0.051, all right? Is everybody cool with that number?
Ms. Kay,
Yes.
Can you show her do it real quick?
Yes. In your calculator, like plugging this in?
No, I think I just forgot how to do it.
Oh, so you're gonna do each of these guys.
Oh, up to 4, yeah. I remember.
Yes,
Okay.
and then you calculate, leave it ugly and long, calculate, and then add all your answers up.
Yeah.
Are you good?
Yeah.
Okay, anybody else? Are we cool? Okay, so, back to this. We defined our null and our hypothesis, we did this, right? Decide the significance level. They literally say, they want me to do this at a 5% significance level. Are you guys cool with what I just said? So, decide my significance level, in this case, it's 5%. Okay, are we okay? And then we're gonna determine the critical value. So, if I'm looking at this from this perspective, okay, we know that we have 40% is like the way it's supposed to be according to the null. We want it to be less than that. So my tail that I'm looking at is the back end tail. Does that make sense? This tail in the back end is going to be my rejection region. This stuff up here is my acceptance region. And what do I mean by accept and reject? We're rejecting the null in that region. We're accepting the null in that region. Okay? So, you guys pushed your numbers out, right? And you got that the probability when x is less than or equal to 4 turned out to be what number? Turned out to be 0.051, okay? Right, are we cool? Is that greater than or less than the significance level? So what is my significance level? 5%. Make this into, it's 5.1%, right? So this is greater than my significance level, meaning it would be shaded in the greater than region. It would be shaded way over here, okay? What does that mean about this is that we are going to have to accept the original null. That the guys saying that if I train them, they're gonna have less than 40% is not indeed true. Yes?
Can you explain how you drew the just how you placed them on where
You mean this particular line?
they? Yeah.
I just know that I have one tail tests and they can go bigger than on this side or they can be less than on this side. Do you remember when I put them up here? There was 3 of them.
Yeah.
There was the first one and then,
So you don't actually have to put like a number.
Correct.
You just know like it should be.
correct, correct. You're basically looking to see, am I at 5% significance, am I in the accept the null zone or reject it, basically? And technically, we're not supposed to say reject because it's negative, but I think reject makes sense to most people when they see that. Like they say, accept the null or do not accept the null. It's nicer, but who cares? We're gonna say reject. So that way we feel, we understand. We are not in that shaded region. We're up here. What do you guys think? Are we okay? So then the last thing, so our critical value had to be either from back behind there, where we calculated the statistic, you did all the math, that's the hard part. Decide the outcome, whether we are going to reject or accept, okay? So you are going to have to write it out in words, and here's where points come in. Therefore, you're going to accept the null. Did that make sense what I just wrote? Because we just said that a minute ago. Okay, there is insufficient evidence at the 5% significance level to suggest that the proportion of drivers crashing their simulators has decreased. Now, do you have to go that in depth? So basically you're saying there's not enough evidence to show that this indeed is true, that it decreased. And that is hypothesis testing. You declare what the original is, you declare what you're gonna look for, you do the math on it, you compare it to whatever the significance level is, and then you say, therefore, I'm going to accept the null, or I'm going to reject the null. Yes,
Is it always gonna be so cut and dry where they tell us the significance, the
Yes.
number?
you will know every time, 5%, 10%, yeah. Yes.
What's that word next to of? Does it
Can't read
say-
my handwriting?
No, I think it might just be glare.
I'm
It
just
says
playing with you.
Of dramatically.
Proportion of drivers crashing,
Oh,
their simulators has decreased. I got really lazy and spelled decrease wrong. Yes.
Could you explain step 3? Like the critical value?
So the critical value is the spot at which it's going to allow you to reject or accept. So I put a line there. We're gonna go into greater detail to find exact numbers eventually. But for now, it's just the fact that it's either to the right or to the left of that 5%.
Okay, thank
Yeah,
you.
yes.
And 4 is 0.051, like step 4.
Yeah, you calculated it, 0.051.
Okay.
You calculated your test statistic. Now, when you get further in stats, beyond me, you're gonna do more than just test statistics, you'll do P statistics and a lot of different types of, yeah, so much fun. Yes, yes, yes.
So did we not do a critical value for this question, or was the critical value?
We
the
didn't
20?
have to because it was kind of like, they told me 5%, so I knew I was to the right or to the left of it. Once in a great while, they're gonna give you the information, you work backwards and figure out where that line is, that's your critical value. So, we don't really need to know exactly where the line is, we just need to know, are we bigger than 5% or are we less than 5% in this case? And for the most part, in this class, we'll be like, are we bigger or less than 5%? Okay, what happens if I change this to, so let's change this up a little bit. And still gonna be at the 5% significance level. I'm gonna have only 3 of the 20 drivers crash. Okay? So 3 or less, basically. So you've kind of got your numbers crunched already, right? What would 3 or less be? It would be 0, 1, 2, and 3. So go ahead and see what that number is, and let's try to figure out how that looks to you. Yeah.
So we said that the probability is less than point. Why would we say that the probability is less than or equal to 4?
The probability of x or less than or equal to 4 is 0.051. So we're trying to compare that probability of 0.051 to 5%.
No, but in the original, when we turned into the probability, we said that x was less than or equal to 4, like the 4 drivers.
The 4 drivers, the probability of the 4 drivers, which is what we calculated.
Okay.
Not the number 4, but less than or equal to 4 drivers. 40%, sorry, 40%, and it should have had a 0.4.
Oh, that makes sense.
Yeah, you should have a 0.4 there.
Okay.
All right, are you calculating this number? Happens now if they declared that 3 or less drivers have crashes, okay? So did you get your percentage? Done, still working on it? So, if this was the problem, you would have the same thing, the same null, and the same alternative, except for this would change to a 3, and then you would calculate your business with the 3. And what do you get when you do it with 3 drivers instead? So 0.016, okay? So that's the resultant that you should get. Is that what everybody got? So that's the resultant that you should get. Now compare it to the significance level of 5%, because we're still doing 5%, And so when I compare it, is 0.016 less than or greater than the 0.05, the 5%?
Less than.
It's indeed less than the 0.05. So if I'm looking at it, right, my 0.05, because we're still talking less than, right? Am I in the reject the null, or am I in the accept the null? So I was less than that 5%, so I'm in this vicinity here now. So I am going to reject the null and accept that alternative. So the alternative is good now, because what I did was I changed the numbers a little bit. The guy was completely wrong when he said we'll have 4 or less drivers, but now with a 5% significance level, I know that with 3 or less, I'm good to go. I'm good to accept the alternative, right? So we're going to now accept the H1. So how do I write that out? If I know now, because over here I said, therefore, accept the null over here, there is insufficient evidence that 5% significance level to suggest that the proportion of drivers has decreased, right? But now we kind of change the number a little bit, so now we are no longer accepting the null, we are rejecting the null, right? So we are going to accept the alternative. Because what the business said is indeed true now. So how do I write that out? Instead of there's insufficient evidence, we say what? There is sufficient evidence, right, at the 5% significance level to suggest that the proportion of drivers crashing the simulator has decreased. Now we're good. Yes?
So do we have to do like that and make it to where we can accept the alternative every time, or is that just like a practice?
So these are the steps.
Okay.
So, like, once you say that now you kind of know, I'm going to tell me what it's about. I'm going to be doing a binomial. I'm going to figure out if I'm going to be less than or greater than, and then eventually we're going to be like either way. I'll explain that probably tomorrow. And then we do our test, and then we look at 5%. Where do we fall? Are we in the good stuff, or are we in the where are we? And then we just state what we found. Literally, that's the whole test in a nutshell.
Okay, so after we did the therefore, we accept whatever after the first one, that would have been the end of that problem?
That's in.
Okay, so I was confused, so I thought we had to like prove that we could accept how they could accept it.
No, I don't even care how we can. The fact is, we tweaked it a little bit. Is it time? Let me give you one to just play with at home. Same problem. Huh?
Oh, okay.
One problem for homework is not going to kill you.
No, I don't know if I'm gonna be able to do
You
that,
are.
so.
The only thing I'm going to change is I'm going to go to a 10% significance level. Okay? So what happens? My bar is a little different. It's 10% now, right? And I'm going to go back to the 4. Back to this original, but I want to do, instead of a 5%, I want to do a 10%. Okay? So I'm not changing anything about, like I just want to see, I want you to see. The problem with statistics is it wasn't good at 4 or less, but when I tweaked it a little bit, we're good to go. Now we're doing it at a different significance level. Statistics to me is a lot of fluff and stuff. Let's have some fun with our numbers, and let's prove what we want to prove. Okay, try that, see how you do.